Some other data. We might have a blob of JSON data telling something about someone's income. But, well, is this a lot or is this not a lot of income? Well, it depends. It depends on what time unit is associated and what currency. If this were euros per hour, it would be a pretty damn good income. But if this were Zimbabwean dollars per year, well, not that much, I guess. Some other piece of data, a word. Suppose a friend of yours left a big cake on the kitchen table with these words on a little note besides it. Would you eat the cake? Well, if your friend is English or Dutch or Flemish, you probably would, because, well, then gift or gift means something like a present, and someone gave you a cake as a present. But I don't know if we have German-speaking folks here, but if your friend is German, I probably wouldn't eat that cake, because in German, gift means poison. So in that case, the cake is probably poisoned and you shouldn't eat it. Another example of data is this prime number. This is a pretty large number. Well, actually, it's not a number anymore because I've replaced one of the digits in this prime number with an X. And it has a reason. Because if I were to write out this exact prime number as it would originally be, that would make this slide illegal in certain jurisdictions. And that's because if you take this prime number, write it out in binary, then put that binary contents into a file, that file would actually be an executable file. And that executable would implement the DCSS algorithm, which is software that can be used to crack the decryption on DVDs. And that's why this prime number is declared illegal in certain jurisdictions, for example, in the United States. So, well, people started to try creative ways of encoding that program into prime numbers because, well, this was a pretty large prime number at the time it was found. And there are catalogs online of all the big prime numbers. So, well, they couldn't skip this one. So it had to be indexed and preserved for next generations, which also meant that this software, which was deemed illegal, also had to be preserved for future generations. So what I want you to take away from this is that data has different meanings under different interpretations. Data is just data, and only we humans, or the code we write, gives it its meaning. And, well, the context we have in which we see the data and the expectations we have, either explicitly given or implicit, because of our expectations, those matter for the meaning of our data. So let's talk about stuff we do with that data. And what we can do with data is we can use it in functions. And we're going to dive into a bit of theory. Originally, I'm a mathematician, so I like to look at this from a mathematical perspective. And what we have probably been taught in school is to look at functions in this way. We have a function which we can represent as a little machine or a box, and we call it f. And there's a value x that goes into the box or the machine, and a value y comes out of it. And then we say that y is f of x. And what's interesting is that mathematicians, they care a lot about what goes into the box and what comes out of it. Not that much about what it does internally, but mostly what can be the x and what values can be the y. And, well, this is kind of how they look at it. And they call the set D. D is a set. It's the domain of the function. And that is where the x's come from, all the possible x's that you can put into a function. And there's also another set R, the range, which is all the possible outcomes of the function. And, well, our function f maps one of the x's in the domain to another value y in the range. And this may look pretty technical, but actually we do kind of the same in our code, right? If we have a function, we can add type hints for that. And, well, we can say that our input value has a type D, and our output value has a type R. And in essence, this is kind of the same as the domain and range we were talking about. So let's look at a more concrete example of that. We could have a function that rounds a number, and we could say that its domain, the values that go into it, are floats, floating point numbers, and the values that come out of it are integers. And this function would map the value 3.84 in the set of floats to the value 4 in the set of integers. We could ask ourselves, could we have a situation like this, where two different values, x1 and x2 in the domain, map to the same value y in the range? Well, if we look at our at our round function, it's actually pretty easy to see that these situations can occur. So there are lots of different numbers that if we round them, they map to the same integer 4. And a function like this, that has multiple inputs that map to the same output, we call those functions not injective. And an injective function is a function for which this can never happen. We will come back to that later. We can also think about if the converse situation can happen, right? If we can have one x in the domain that can map to multiple output values in the range. Well, a mathematician would say this cannot happen, at least not if we have a pure function. And in programming, if we work with pure functions, like in a functional language, this cannot happen. But in PHP, we can create all kinds of impure functions that can have different outputs for the same input depending on other circumstances. And those functions use, for example, randomness, some global or local state, I/O, either through the file system or the network, or they might depend on the system clock. And those functions can have different outputs for the same input if we call them multiple times or at different times or in other contexts or with other contents of files on disk, for example. Another situation that we might wonder about is if we have an x in our domain that we cannot really nicely map onto one value from the range R. What should we do with that? Well, mathematicians have a quite simple way for that. They can just define the set D to exclude that value x. So they kind of create a hole in the domain. And with programming, we cannot easily do that, at least not in PHP. We cannot say, well, this function accepts any integer except the value 0. We cannot define that as a type. But what we instead do is we just throw an exception, and in that we use a construct like that to, well, kind of exclude stuff from the domain or not map some values in the domain to a value in the range. What does this have to do with the topic of this talk, representation and interpretation? Well, let's look at these functions again. We had a function round that rounds a float to an integer. And what we see is that I've put a kind of a non-scientific axis on the right-hand side. We can see that the domain and the range, the sets of floats and integers, they're kind of at the same level of abstraction. They're both numbers that we can do calculations with and stuff like that. So they live on the same level of abstraction, but it doesn't always have to be the case. We can also have a function called serialize money, for example, that maps from the type money, which may be kind of a value object that we created ourselves for working and do calculations with money, to a string. And for example, it would, well, if we have a money object that represents 10 euros, it would map it to the string 10 euros, for example. And this function, it kind of lowers the level of abstraction, right? We have a money object that's pretty rich. We can do all kinds of calculations and comparisons with it. We can convert it to another currency or something like that. And string is kind of pretty dumb. We cannot calculate monetary amounts with strings. So we kind of lose a level of abstraction. Another example would be something that encodes a string as UTF-16 that would map from a string into a byte array. And well, while string is, in this case, pretty high level of abstraction, we can do substrings with that. We can convert it to uppercase or something, or to lowercase. A byte sequence is dumber than that. We cannot convert a byte sequence to uppercase because, well, we don't know what the bytes mean, right? It could also they could also be part of a floating point number or something. So uppercasing is not really sensible operations on a byte sequence. And I like to call functions like this that lower the level of abstraction, I like to call those representations. These are functions that translate a higher level concept into a lower level representation. They typically support all the values in the input domain, so they don't have these holes or these values for which they throw exceptions. Ideally, such a representation is lossless. We will come back to that later. And in essence, they just, well, they return the same data as their fed, just in a different form. They map it to a lower level representation of it. We could also have the converse. We can also have functions that raise the level of abstraction, like, well, the converse of encode as UTF-16 would be decode from UTF-16. It raises the level of abstraction from a dumb byte sequence up to a richer string, which we can work with. In the same way, we can also have a function parse money, which converts a string representation of our monetary value back into our money value object that we can work with. And well, these are kind of the inverse of representations. They translate a lower level representation usually back up to a higher level concept. And typical for interpretations is that usually not all the input values of the domain are supported, right? Not every byte sequence would represent a string under certain encodings. Not all strings represent a valid monetary value. If we were fed the string foo into a parse money function, I would expect that to throw an exception. In essence, not accept the value foo as a valid part of the domain. And also these functions, they return the same data just in a different form. And this is not really a fixed classification, but just a way of looking at functions and, well, kind of seeing common characteristics. So why do we have these representation and interpretation functions, right? We, as programmers, we like to work at a high level of abstraction. We don't program in assembly often, but in a higher level language, like PHP, because it's easier to work with and we have a higher level of abstraction. And for most tasks, PHP isn't even a high enough level of abstraction. And we work with a framework or with libraries to raise the level of abstraction even further. So why do we go back to lower levels of abstractions? Well, it's kind of logical if we think about how we store our data, because we store our data like this, like magnetic grains on a platter, or how we send our data over a network, right? We send our data over a network like this. It's just small light beams, light pulses through a cable. We cannot send a money value object through a cable like this. We have to dumb it down all the way to light pulses before we can send it over a cable. So what this looks like in practice is something like this. We have a money value object and we want to send that over the network or store it on disk in a database or something like that. So we start at a really high level of abstraction and we have to dump that down to a string. Then we convert the string into a byte sequence and then it goes into the operating system. And well, eventually that converts it along with the hardware. It converts it into light pulses or magnetic grains, etc. These are put on disk or, well, sent over the network. And then at the receiving end, we raise the level of abstraction again up to byte sequences, up to strings, and eventually we hope to get our money value object back. So I promised to tell you something about string escaping. For example, string escaping to prevent SQL injection, to prevent XSS. And because of that, string escaping is often seen as a security-related topic. And what I would like to argue in this talk, as you will see, is that this doesn't have to do with security that much at all. So let's look at escaping for SQL, right? We could have an example like this. I hope you have seen this before, why we do this. So we have a username, which we get from the post data, and we execute an SQL query using some kind of database abstraction layer functions, where we select all the users with the given username. And we have learned, I hope you have learned, that you should escape that string that we get from the post data, because otherwise someone could enter a username that contains a piece of SQL, like the SQL to drop the table users. And well, this would be put into the query unescaped, and it would drop all your users table. And we have learned that we should protect against these malicious behavior. But SQL injection, in a sense, doesn't have to be malicious, right? If someone has a username, someone is named John O'Shea with a single quote in it, that this would also break your SQL query if you wouldn't escape that string. There's no malicious intent behind this. It's just, well, someone's name. John O'Shea can't help that his name contains a single quote, but we still have to escape this data, even if we don't have to assume any malicious intent or something. We just want to make sure our SQL doesn't break, and we put the string into it as we intended to put it into the query. It doesn't even have to be user input, for example, that we have to escape. We could also have something that gets a username using some API. And well, if that can return the string John O'Shea, we have to escape that result string before putting it into our query to ensure, well, that query contains the string as we intended to have it escaped, because otherwise it could break our query and, well, the string gets interpreted in the wrong way. So it doesn't matter where the username comes from. It's just we have a string and we want to represent it as the SQL representation of a string. And what I want to tell you with this is, well, that string escaping is not a security measure. It's just a way of properly representing our data for the use case we have. We have a string, we want to use it in SQL as a literal. We have to represent that string as an SQL string literal. So what this looks like as a function, as we've seen before, is if we have a function db escape string, well, that maps from the domain of strings to the domain of, well, let's call it SQL fragment. It's kind of awkwardly named because it's not a real construct. It's not a complete thing in SQL. And it has to do with how most database escape functions work, because they often return the string without surrounding quotes, right? There are double quotes around the John O'Shea here, but it's just to indicate that it is a string. They are not part of the string ourselves. It would be better, and PDO uses an abstraction like this in the PDO quote function, if such a function was called as SQL string literal. That would make it clear that we would escape, that we would really represent this string as an SQL string literal, and add the extra quotes around the function, around the string. So this would really take a string and return the representation such a string would have in SQL. Or if your database system supports it, prepared statements are always better for this situation. But for illustration purposes, I use this example. So such an SQL string literal function would map from the domain of strings to the domain of SQL string literals. And it would map, well, the string John O'Shea to O'Shea with the single quote escaped and wrapped in quotes. And if we think about string escaping in a framework like this, chaining all these escaping, for example, if you want to put JavaScript inside HTML and escape for that, which is quite a difficult task, it becomes much easier if you think about these escaping as representations. For example, if we have a name that we would like to put into a piece of JavaScript, and then that piece of JavaScript we want to include in an HTML snippet, and then we would like to insert that HTML snippet into a database using an SQL query, well, we first convert the name to a JavaScript string literal. We use that to create a piece of JavaScript. We then represent that string with a piece of JavaScript as an HTML attribute value, which again involves escaping. We use that to construct a whole piece of HTML. And then that HTML string, well, we represent it as an SQL string literal and use that to build our SQL query. Why I'm saying this is because I've often seen this go wrong. I've seen people do stuff like this. So they put this into a script that's run at the start of every request, and they just go over all the request data, and they just escape it for use in the database and throw HTML entities over it. And then at the end, they can say, well, now my input data is safe, and in the rest of my script, I don't have to worry about this anymore. What they do end up with is all kinds of double escaping and extra quotes and escape sequences that shouldn't be there. This is kind of what magic quotes did in really old versions of PHP. So don't do this, right? What this code actually does is assume that all pieces of request data that come into your script are used into an SQL query that's then printed into HTML, right? We represent the data for use in an SQL query for use in HTML before we even know what we're going to do with that data. So this is kind of a premature representation of our data before we even know what we're going to do with that. In the same sense, I've seen code like this. People will also loop over all the request data at the beginning of a script, and if they detect something like that in those request data, they detect something that looks like SQL injection, for example, a drop table statement or something like that, they just, well, abort the whole script, and because they are scared that it would lead to SQL injection. But what if I made kind of a web application and I would like to add the contents of these slides into it? My slide also contains the word drop table. My slide is not malicious. Or I would write a blog post about SQL injection or SQL in general. It would also contain the words drop table, and it wouldn't be malicious. And as long as we properly represent that data for how we're using it, it cannot harm anything, right? So also don't do stuff like this. Data in itself is not evil or malicious or something. It all depends on how we use it, what we do with it, and if we properly represent our data for the use case we're having. So these were already some examples of what goes wrong with representation and interpretation, and I would like to look at some more examples with you. There's something that I like to call misrepresentation. And, well, we've talked about a function that serializes money into a string. And, for example, such a function could map the value that represents 10 euros, which would be some kind of PHP object, into the string euro space 10. That would be fine. But we could also create another version of serialized money, another implementation that would map that same money object to just the string 10. Doesn't seem too bad until we realize that if we have another monetary value, for example, 10 American dollars, that function would also map this monetary value onto the same string 10. In other words, this function is not injective. And what's the problem is, well, if we talked about transmitting these values by lowering the level of abstraction and then raising it back up again. Well, if we were trying to parse that monetary value again, to what monetary money object would we need to parse that, right? We don't know anymore if that value represented 10 euros or $10. And of course, this example is really simple. And you would say, well, that doesn't happen to me. I don't do stuff like that. Well, let's look at some other examples of this same pattern. For example, we could have a date time that we want to represent serialized into a string. If our date time is some moment far in the future, we even have a time zone for that in Amsterdam time. And we represent it as a string, which also contains an offset from UTC. Seems right. But within the European Commission, people are now talking about maybe abolishing daylight savings times. And that might also alter the time zones certain regions are in. So I don't know if in 2022, Amsterdam time is still an offset of 1 when compared to UTC. So by throwing away the Europe Amsterdam here, we're losing data in essence, and we don't know if we can faithfully parse the data back to a higher level of abstraction again. Or for example, we could have a fraction that we would represent to a float with a certain number of digits. Well, we don't know if that floating point number represents the exact fraction 1/3 anymore. It could be another fraction that's really, really close, but just differs into some subsequent decimals that we've cut off. Or I've seen people who try to encode strings with all kinds of emoji characters and stuff like that in it as ISO 88591, which is also called Latin 1 encoding. And that doesn't support all those emoji characters. So, well, it depends on what your function does. It probably throws them out or something. But again, you lose data here. So one thing to keep in mind is that lossy representations cannot be faithfully reinterpreted to the data we had before. So this is why you have to make sure your representations are injective, because an injective function can always be inverted back, and that ensures that our representations can be interpreted back to the original data. Another problem that we often see is misinterpretation. And it's something like this. We have a byte sequence, and we can decode the byte sequences from UTF-8 into a string. What we have to keep in mind is that not all byte sequences represent valid UTF-8 strings. So it actually looks more like this. The valid UTF-8 sequences are a subset of the set of all the byte sequences. And some of the byte sequences, if we try to feed them into a function that would decode from UTF-8, that would throw an exception because, well, this is kind of a part of the domain that's not supported. A problem is that there are also other byte sequences which partly overlap with the UTF-8 byte sequences that are valid Latin 1 byte sequences. And for those byte sequences, we can also, well, decode to a string from Latin 1 encoding, ISO 88591 encoding. And because these sets overlap, for byte sequences that are in the overlap between these two sets, we can feed them into both functions. And these would also map them into a string, but into another string. So depending on which interpretation we choose for such byte sequences, we get back another string. And well, this is why you often encounter these funny characters if someone messes up the character encoding. These byte sequences are valid as both UTF-8 and Latin 1, and they chose the wrong interpretation for them. So what essentially happens here is we cannot distinguish, if we have a byte sequence, we cannot know whether it is, without further information from context or expectations or something, whether it is intended to be a UTF-8 byte sequence or a Latin 1 byte sequence. Well, luckily there's a PHP function that says that it can. There's mbDetect encoding, which says that it detects the character encoding. But for a value that is in the overlap between these two sets, how can it possibly do that, right? It is valid UTF-8 and it is valid Latin 1. We cannot know which one is meant. So don't use mbDetect encoding. It actually just tries a sequence of encodings until it gets one that is according to which the byte sequence is valid, and it returns that one. But it doesn't mean that that's also the character set that was intended, right? So again, the meaning of data, as we've seen before, comes from our own interpretation of it. But if we have a wrong interpretation, well, the meaning of data is also not how it was intended. What can we do about this? One possible solution is to use something that I like to call an interpretation hint. We kind of set the expectations for how we should interpret data by storing or transmitting the desired interpretation along with our data. And there are examples in real life of this. For example, music staves. If you look at sheet music, the symbols at the start of the bars, they indicate how we should interpret the notes behind them. Without the symbols at the start, we wouldn't know which notes were written down here. So these symbols, they tell us how we should interpret it. But also in more technical situations, we encounter these. For example, HTTP headers. We have a content type header, a content encoding header, a content language header, and these all tell the browser how it should interpret the data we send. If we send certain data with a content type text plain, the browser knows to show that as plain text. If we send it with a image /PNG, it knows that it is a PNG image, although it may also, although the browser could have also represented that as plain text. But because of the content type, the browser knows how to interpret that data. Another example is the Unicode byte order mark, and I would like to go a little bit further into that. with a byte order mark in UTF-16, you can have UTF-16 little endian and you can have UTF-16 big endian, and you can interpret data according to the one or the other. And again, these byte sequences, the byte sequences that are valid UTF-16 little endian and the byte sequences that are valid UTF-16 big endian, they overlap. So if we have a value that's in the overlap between those two, we don't know how to interpret it. We can interpret it as both. What the byte order mark does is, in essence, it creates these different sets that have no overlap anymore, because all the values in the left set, they have one type of byte order mark, and all the values in the right set, they have another type of byte order mark. So they are necessarily different. One string cannot have, one byte sequence cannot have both the one byte order mark and the other byte order mark. So these sets are pulled from apart. They cannot overlap anymore, and we know what kind of value it is. Another possibility is to add hints to our variable naming. If we add a suffix to our variable names, like message UTF-8, we know that it is a message that we should interpret as a UTF-8 byte sequence. If we add username SQL, we know that the username is already represented as SQL. If we have title HTML, we know that it is already represented for use in HTML. And this might help us to spot some errors earlier. As an example, if we emit a header that some content is plain text with Latin 1 char set, and directly below that we print something that we indicate is represented as UTF-8, this is probably wrong, right? There's a mismatch between the header in which we say what kind of content this is and the actual content we send along with it. If we strictly use a SQL suffix to indicate values represented properly for using SQL, well, if we put something into a query that doesn't have an SQL suffix, that's probably not correctly represented, and we suffer from SQL injection. If we run HTML entities over something that already has an HTML suffix, that value is already properly represented for use in HTML. And if we run HTML entities over it again, we double escape it. Probably also not what we want. So this all is a handy framework to reason about stuff, but it gets a little bit more different if we run into PHP string type, because while creating this talk, I discovered that PHP string type doesn't really play nicely with this. And that's because, well, we always showed the encode as UTF-16 function like this. It maps from a string into a byte array, which lowers the level of abstraction. But in PHP, this is not really the case, because PHP string type is actually just a byte array. PHP doesn't really have a string type at a higher level of abstraction. For PHP, every string is just a byte array, and PHP just handles it as separate bytes. So in essence, our encode as UTF-16 function, it doesn't change the level of abstraction at all. The string and the byte array are actually just the same, and it maps from a domain onto itself. And in this way, we don't have a higher level of abstraction to work with. Instead, if we want to do string operations in PHP, every time we kind of temporarily interpret that string, or in essence that byte sequence, up to a higher level of abstraction, and then we forget it right away. So every time we are reinterpreting it again, like we just put on certain classes, right? Hey, I have to work with this string, which I think is UTF-16. Let me put on my UTF-16 classes right now. So we don't get this higher level of abstraction to work with, and instead we are interpreting over and over again. And that leaves room for misinterpretation, right? Because we could just as well interpret that same byte sequence, that PHP string, as if it were UTF-8, and we would get back another string, or it has another meaning. So what can we do about this? Well, we would like to have some more accurate types for these strings. If we would have a better type system which contains actual strings at a higher level of abstraction, it would make misinterpretation much more difficult. And if a programming language does not provide these types, well, maybe we can do so ourselves. So we could create value objects for them. And I would like to show you how that could look like. We could create a class which we can call UTF-8 bytes, which represents a sequence of bytes that's valid UTF-8. We add a private constructor for that. Internally we just store these bytes as a string because, well, PHP string is actually just a byte sequence. But we hide this implementation detail by making the constructor private and only using a static constructor, which creates such a type from a PHP string. And we also have a function to represent that, to convert that byte sequence back to a PHP string because, well, we have to feed it from a PHP string, and eventually we have to convert it back to a PHP string. In the same sense, we can also create a type for a sequence of Latin 1 bytes, which looks almost exactly the same. And if we have those, we can also create something that, well, I just call a real string here because we cannot rename it string because it is a reserved keyword. And this is a value type at a higher level of abstraction for a string. Internally, we represent that string by its UTF-16 representation. Like, for example, JavaScript strings also do. For some reason, UTF-16 is a popular choice for this. But, well, we've hidden this completely due to the private constructor, and we use only static constructors in practice. So we have a static constructor to create such a sequence, such a string, as an interpretation of a set of UTF-8 bytes. And in the same way, we can also construct such a string from Latin 1 bytes, which has kind of the same implementation, which I have omitted here. And we can also represent that string back to those byte sequence. So we have a function toUTF-8, which returns a UTF-8 byte sequence. And in the same way, we have a function to ISO 88591, which represents as a Latin 1 byte sequence. And this is just a conversion logic, but the fun part is that if we have such a real string type, we can also create our actual methods at a higher level of abstraction on them. So we can create a function to concatenate strings to another real string. And we know that we can do so by just concatenating their UTF-16 sequences together. Or we could do substring operations with them, which again return a real string. And how we could use this is, for example, if we have one file which we know to be UTF-8 encoded, so we could get the contents of that file, say, hey, this is a UTF-8 byte sequence, and then we can interpret that UTF-8 byte sequence as a string. In the same way, another file that is Latin 1 encoded, we could read those bytes, create a byte sequence of it, interpret that byte sequence as Latin 1, and create another real string from it. And at that moment, once we have our string 1 and string 2 objects, the original character sets that these strings were in don't matter anymore, right? We can do all these higher level operations at the level of abstraction we want to work with. So we can concatenate them, take substrings of them, and then at the end, once we finished our calculations at a higher level of abstraction, we can dump them down back to lower levels of abstraction because, well, eventually we just have to, the print statement only works with the PHP strings. So we can output them as UTF-8 and then convert that into a PHP string and print that out. So to go back to a diagram we had before, essentially we are converting this situation with the string, which is kind of the same as a byte sequence, and the UTF-8 byte sequences overlapping the Latin 1 byte sequences. We convert it to a situation more like this, where there are all different types separated from each other, and we can convert those types between those types to lower and higher levels of abstraction and work at a higher level of abstraction like we want. So this is kind of what you could do with value objects to raise the level of abstractions and avoid these misinterpretations. We do these interpretations once and not every time over and over again, leaving room for errors. Of course, this is no silver bullet. it comes with quite some additional overhead, both in terms of performance and in terms of writing all these classes and stuff like that. So would I recommend a strategy like this for all your code? No, probably not. But if you have code that deals with a lot of character set mangling and stuff like that, where your logic is really difficult to get straight, you could try something like this, or you could use it as a scaffold to get your logic right. And then if you, discovered how the situation works, write your algorithm normally in using PHP's built-in functions. So to recap, we've looked at data and how its interpretation actually defines its meaning. We've looked at how functions operate on data, mapping them from a domain into a range, and interpretations and representations, which are functions that kind of lower or raise the level of abstraction. We've looked at string escaping, and how it's actually just a matter of representation of our data for the use case we're having, and not necessarily a security measure. We've looked at how representation and interpretation can go wrong, and what we can do about that. The strange role of the string type in PHP, which is actually a byte sequence and does not achieve a higher level of abstraction, and how we can use value objects to, kind of circumvent that problem if we want to put enough effort into it. But the main part I want to take you away from this talk is that the meaning of data is always defined by how we interpret it. How data is used defined what it means, and not the data itself. Data is not evil or good in an absolute sense. It's only evil or good depending on the way how we use it. So this was my talk. Thank you very much. I guess there's a Q&A module for questions. So just throw them my way. I would really appreciate if you would leave some feedback on joined in. I guess I can share the link in the chat later. So are there any questions?
Hi. Well, I was looking at all the communication channels, but I haven't seen the questions popping up. We do have a Q&A mode enabled now, but I don't see any questions at this point. Let me go figure out on the other channels. I don't see in Slack. At least there is a reference to your joined in page. That's it. But
well, if there are any questions at a later moment, I'll just be around for the rest of the meetup. So feel free to throw them into the chat, and I can answer them at that moment.
Wait. We do have a question.
Yeah. So if the Symfony string component correctly addresses this problem, yes, partially. I don't think it properly distinguishes 3 different levels of abstraction. So you always know at which level of abstraction you're working. But I don't think if you're working with a string as in a byte sequence, it does not contain using which encoding that byte sequence uses. So if you want to raise that level of abstraction, you can go wrong there. I don't think it completely solves this problem, but I don't know the final design. I've given some comments at an early design for the string component, but I don't know the final design and if it completely solves this problem.
There's another one.
All right. Do you factor good data understanding in your hiring process? No, not exactly in this way, but I kind of look at if people can understand the role data plays, and that the interpretation of data is not absolute. It always depends on the use case.
Yeah, there's a one from outside the platform coming in.
Yeah, I see it.
And they're all now the questions are coming in.
Right.
So
yeah. So can type hints and return type hints represent the DNR for the function or method? Yeah, in PHP, well, types are and classes and the built-in types that we have are the closest we can do. Union types make this a bit easier because, well, if we have a set of that's a combination of integers and strings in PHP 8 union types, we can create a union type for that int pipe string and represent that. So they come pretty close, but we cannot express all different sets as PHP types. For example, right, all the integers except 0, we cannot represent that as a type in PHP. Maybe if we create a value type for that, we could create a value type non-zero integer and check in the constructor whether the integer is actually non-zero and then throw an exception there. And after that, well, we could work with a value object that's just a non-zero integer. So that would be a possibility. But in general, well, mathematical sets are more powerful than types or classes in PHP. So not everything can be represented with types in PHP.
Okay, well, it seems to me that was all for the questions. So,
Right.
well, Arnoud, thank you very much for this inaugural meetup on the internet.
You're welcome.
I really, really want to thank you for your patience in solving the technology the struggles that we had in the beginning. I hope you enjoyed it.
I really did. Yeah.
I do see a few more people coming up. How are we doing with time? We're a little bit over time, but yeah, it's a meetup, so that's okay. All right. It seems that these are all celebrations for your talk. So thank you very much.
Right.
Folks, don't leave yet. Yeah. We have a live audience here. So next up is Juliette. We're going to take a very small break. I will replay a video I showed earlier. And after that, you will be welcome to join us. And don't forget, we have a raffle, and the raffle will be elephants.
Till the time.
It's now 1:15, so give us 10 minutes. So 25 over the hour, please. All right. And I see you soon. And I lost the link to the meeting.
Displaying the event info at the moment.
Yes. And I'm too many screens.
Welcome to the PHPBenelux virtual meetup. We will bring knowledge to the PHP community every month over the internet to your home or office. We are starting at 7 with welcome and introductions. Our first speaker, Arnoud, will start at 7:10. Around 8, we have a 10-minute break. Juliette will start her session at 8:10, And around 9 we have our closing notes and a raffle, of course. We would like to thank the PHP community in the Benelux. They stepped up and created local PHP communities with monthly meetups. We are very grateful to have been a part of this. We would like to thank our speakers for stepping up and helping us getting the virtual meetup going. So from the bottom of our hearts, thank you Arnoud and Juliet for doing this. We also want to thank our sponsor Into IT for stepping up in paying for the platform and logistics we use today. They are also our sponsor, raffling tonight's prizes. Today we have 2 elephants to raffle thanks to our sponsor Into IT. We love to keep the conversation going, so join us on one or all of these social media platforms for during and after the event. Sit back, relax and enjoy the show. See you at the event.
Okay, this is a very quick test to see all the technology works here. Juliet, can you activate the mic and camera?
Camera, no, share screen. The screen sharing still not working.
Nee.
Mic on. Camera.
We see the top of your head.
That's quite okay for now. And then screen sharing. If I say opening browser, let's see.
Yep, we see your screen.
Is that working? Now, do you see more than just the top of my head?
Now we see you in full. Well,
Yeah.
just above the waist.
The part you want to see.
Yep.
Okay. In that case, it looks like we're set.
Yep.
So over 5 minutes to 5 minutes. So
Yep.
Do I stop sharing my screen for now,
Yeah.
or leave it at the first slide, so people know what's coming up?
Yep.
Do I need to turn off my mic? And in that case.
Just 1 minute warning.
Okay. Hello, everyone. Can you all hear me? Can you all see me? Can you hear me? Can you see the slide? Am I getting a thumbs up from the organization here? Because I'm here in lovely Belgium together with Mike and Paul, who are kindly hosting me here. And I noticed that there's people from all over Europe attending, so that's great. In case you're worried, I might cough at some point during the presentation. That's not COVID, that's me being a smoker. So do not get worried. I'm also going to give 2 additional caveats at the beginning of the talk. First, the slides are all language agnostic. So while this is a PHPBenelux meetup, and I'm going to focus on PHP, you might see things on the slides which are nothing to do with PHP. But do not worry about that. We'll talk you through that. Another thing is, this is Regex Foo. This is not Regex for beginners. This is Regex Foo. So if you've never heard of Regex before, bear with me. It might go a bit too fast for you and might go over your head, but you might still pick up something while you're learning the beginnings later. Right, so let's get started. I'm the author of the Pluralsight Regex Fundamentals course. So if you do want to learn the beginnings, that's a good starting point. And we're going to talk about Regex. And what are Regex? Well, wildcards on steroids. Regex is all about pattern recognition in text. And Arnold was already talking about data validation. Regex is one of those mechanisms you can use for data validation. It's also sometimes used for data transformation. And you think, like, okay, so great. So there's one way to use it, isn't it? No, unfortunately. At some point, someone thought creating a Regex engine was a good idea. And then someone else thought, I can do this better. And someone else thought, no, I can do it better. And the next person thought, yeah, but I want another feature which is not available yet. So basically, we ended up with about 41 different engines. And the trouble with that is, of course, that they're all slightly differently, and they all work slightly differently. So what we're going to talk about and focus on is the overlap. And if I go back one slide, how many, and please give me feedback from the Slack I'm saying to Paul and Mike here, how many Regex engines are there in PHP? Are they used in PHP?
I use only one.
Paul's saying he uses only one. Mike? Are people responding in the Slack?
PHP. No Slack.
Or in the chats? Well, I'll give it away. Originally, there were 3. There's now 2. POSIX was removed. The POSIX regex functionality was removed in PHP 7. And the one which most people know is PCRE. But there's also the MB string regex implementation, which uses a different engine. It uses the Oniguruma engine, and I always struggle in pronouncing that word, but it basically means Devil's Chariot, and it comes from Ruby. Right, so let's go back to that overlap, and we're mainly going to focus on PCRE. Even with all those different engines, a lot of them are different flavors of PCRE now. PCRE is basically semi-standard, but still not the one engine to bind them all. PCRE means Perl compatible regular expressions. Once Regex started, Perl was the one making the most forward thinking strides and making the most advanced features, and that's why PCRE became widely adopted. So what are we talking about? Just to make sure we got the terminology right, this is Regex, a regular expression. Then that's often delimited by delimiters. Delimited as in saying this is the beginning of the regex, this is the end. Now in PCRE, in the PHP implementation of PCRE, you can actually use different delimiters than the slashes. In most other programming languages you can't. In PHP you can, and it's an awesome feature. My preferred delimiter is actually the backtick because it's a character I rarely need to match in a regex itself. But you can also use a hash character or an @ character. You can't use the A to Z or 0 to 9, but you can also you can use brackets. You can use like a curly opening brace, curly close brace to delimit your regex. There's a lot of variations possible. Use what makes sense to you. The reason not to use the forward slashes is because it's a character which is often used in the regular expression. And if you also have it as a delimiter, you will need to escape it. So it's a good reason not to use that as the delimiter, even though it's the default. And lastly, we have modifiers. Modifiers change how a regex behaves. So we've got the terminology right. I'm going to very, very briefly go through the basic syntax because I presume you all know that. So I'm just going to quickly show it. Literals, we have wildcards, we have quantifiers, we have character ranges, we have grouping and alternation, we have anchors, shorthand character codes, and then we have the modifiers. And I'm not listing everything here, but this is the general gist of it for the basic syntax. I presume you all know that, and we're now going to move on to the fun stuff, to the intermediate regex tips and tricks. First thing first, don't use a hammer when you need a screwdriver. If at all possible, do not use regex. And you're saying like, hang on, but isn't this a talk about regex? Yes, and I'm advising you not to use regex. There's a reason why Jamie Zawinski said this very famous quote, now you have two problems. Regex, it's incredibly powerful. However, it's often quite complex to get it right. And even when you do get it right, quite complex for the next person to understand what you did there. So there's a lot of situations where you can use other tools. Think of string positions, substring. Think of the DOM document implementation in PHP. Think of the tokenizer if you want to parse PHP code. Think of the new functions in PHP 8. String starts with, string ends with. I mean, those kind of solutions will generally be much faster, even if you have to loop through 5 different values, than using a regular expression. So only use a regular expression if this can't be done in a reasonably simple way in any with any other of the tooling available. Next, a quote by Marie Curie, and I'm using quotes here to hope that they will anchor the information I'm trying to convey for you. If you remember those quotes, then you hopefully remember the message I gave with it. So nothing is to be feared, things are only to be understood. And what I mean by this is to understand what regex does, you need to understand the difference between allow listing and deny listing. With an allow list, we basically have a list of valid values. We have an input string, we compare it against all the valid values, and then say, okay, this is valid. With deny listing, we do the opposite. We have an input string, we have a list of invalid values, and if it matches that, we know it's invalid. In most cases, and there's only very few exceptions to this, regex will be a form of deny listing. Regex will not tell you whether something is valid. It will tell you whether it isn't invalid. So say a Twitter handle. A Twitter handle, if you look at the API documentation, is very well documented. It is a characters string with characters between A and Z, between numbers between 0 and 9. You can use an underscore, and it is between 1 and 16 characters. If you have a regex to check whether something is a Twitter handle, you can determine whether it validates against the pattern of a Twitter handle. But that does not mean that handle is actually used. You'd still need to make an API call to check whether that user exists. And if you say, yeah, but hang on, locally, I don't need to make an API call, do I? No, but say you have new user registration and you have limits on what a username can be. Fine. You can validate it with regex. You can check, okay, this validates against the rules we have, but you still don't know whether that user is not already registered. And you would create a duplicate username, which you don't want. So you'd still need a database call to check that the username isn't already in use. So it's always basically a form of deny listing and not of allow listing. And this is important to realize. Not all matches are made in heaven. Okay. Basically, regex can be slow and can be badly performant. It can be memory intensive. The reason for that is that regex will always favor a match over a non-match. What that means in practice is if you have a really long string and you have a semi-complex regex, the regex engine will try to match that regex against every single part of that really long string until it's exhausted every single possibility of making a match before it returns and says, okay, we didn't have a match. So this can really take a while, and if your regex isn't optimized properly, that can really throw your engine and throw your application into loops. What I mean by this is the best way to set up your regex is to set it up to fail early. Fail quickly, fail early. Set your regex up to fail. Of course, you want it to pass, but make sure it fails as early as possible instead of trying to exhaust all the possibilities if you already know there can't be a match. Only elephants remember everything. I already said performance, memory intensiveness is an issue with regex. Well, what I mean with only elephants remember everything is there is a trick. You can actually tell a regex not to remember things. We know that the the parentheses, which are used for grouping things and for alternation and for grouping things for repetition, we know those mean that something gets remembered. So that those parentheses have various meanings. Well, let's use them to forget matches. If a subpattern which you just need for alternation or just need for repetition, but you don't need it for further processing after you've had the match, then you just make sure you don't remember it. And you do that by using the question mark and the colon. If you do that at the beginning of the parentheses, then whatever is in that parenthesis, whether it matches or doesn't match, the match will not be remembered. Less is the new more. Yes, you heard it here first, if you didn't hear it before. Less is the new more. I already said, and I keep hammering this point, performance is an issue. So to understand why performance is an issue, you need to understand backtracing. And I'm going to show you an animation. Now I'm going to shut up for a moment while you watch that animation and see what's happening. All right, we've got a semi-random phrase. Yeah. And then we're going to have a nonsense regex, but the regex isn't important here. It's the behavior which is important. Did you see what just happened? As soon as regex hit a wildcard with a star quantifier, it surged forward to the complete end and only very, very slowly stepped back. And it will keep doing that, very slowly stepping back until it has a match again. Okay, here we go. And oh dear, quantifier. And it goes forward again and very slowly steps back. This is called backtracing. And this is what makes your regex slow. I can see Michelangelo looking at his screen in fascination. So I'm hoping that you're looking at the screen in fascination at home as well with the same look. Now I'm going to show you the opposite. Because regex doesn't always have to be greedy. By default, it is greedy. That's what the searching forward and stepping back slowly is all about. But the regex doesn't have to be greedy. So similar phrase again, similar nonsense regex. And again, we've got some quantifiers. And here you see, instead of searching forward, it is very slowly stepping forward to see if it can find a match, because I've set it up to be non-greedy. And it will capture once it's got a match, but it won't do the searching forward and stepping back as much. And to do that, we use reluctant quantifiers, and that's adding an extra question mark after your normal quantifier. That makes your regex less greedy, or rather, it makes it ungreedy. It will still try to make a match, but will try to do so with the least amount of characters as possible. You can also make a regex possessive, and that's instead of the extra question mark, you add an extra plus. And that will also limit backtracing. Whether it will actually make your regex faster depends on the individual use case. But being aware that regexes are greedy by nature, and you can make it ungreedy by using reluctant quantifiers, is something which is valuable for the future. For your future, actually, when you are writing regex. Right. Being negative isn't always a bad thing. Remember that backtracing we just talked about? One of the beautiful things about using a negative character class, and that looks like this, the little roof character at the beginning of the character class makes it negative. It says, do not match this. Using a negative character class prevents backtracing, because once it's not matched something, it's not going to go back on it because it doesn't match. There's one little pitfall here. Do not combine this with multiple of the shorthand characters, so the \S or \W for word characters or space characters, because you can't not match a space character and not match a word character at the same time. Basically, you throw your regex engine in infinite loop if you do that. So do not use those, and there's more about those later. Explore your boundaries. Well, most of you will have seen the anchor, the roof character as start of string and the dollar as end of string before. But do you know there's more boundaries you can explore? And I see this hasn't been automated enough. Okay, so there's word boundaries, and word boundaries, you can say, okay, yeah, but I can say, I want a word character, and then I want a non-word character, as in I use the \W. But that would still capture that character. Word boundaries, like the anchors, like the roof character, like the dollar sign, are non-capturing. It will just say it's basically the space between characters, which is nothing, but it will say it's a boundary. And basically for boundaries, you can use the \B being the boundary between a word and a non-word character, or in negation again, the capital B. I'm hoping I'm still making sense and that there's not a lot of people in Slack or in the chat now with question marks above their heads, but we'll see. Okay, next up, first love is the deepest. You've all had a first love, I hope. I dearly hope. What I mean by this, Regex will try to match, and it will stop searching once it's had a proper match. So if you want to match, say, cat and caterpillar, how would you make a regex for that? If you would use parentheses and then cat, and then the boundary of the or character and then caterpillar, caterpillar will never ever match because it will stop once it's had cat. By the way, this is different in PCRE than in POSIX. In POSIX, it will go for the longest match. In PCRE, it's the first match. Nice. So if we're looking at this regex, this is an example for a regex for HTML color codes. Yes, you can have a 3-character one. You can have a 6-character one. If we ever want the 6-character one to match, we need that as the first part of the sub-pattern and not as the second part, because otherwise it would always match just the first 3 characters and it wouldn't even look at the next 3 characters. Yeah? Okay, and normally I would do a show of hands, but that's difficult with this online presenting. Hear me? Probably not then, or maybe microphone. My screen suddenly went completely blank. Hi.
Yeah, it looks like we have a technical problem here. So just hang on a second. Yes, there appear to be some problem. We're rebooting the computer right now, so bear with us for a moment. As you can hear, Juliet is apologizing as well. But yeah, meetups, this happens. So just a few more minutes, and we will be streaming back. All right.
Okay.
We have visuals.
We have visuals. Yes. Is my sound going as well?
Sound check, good.
Okay. Let's see about screen sharing. Yes.
I see your screen.
Okay,
and I see your
and
slides.
yes, and I'm gonna turn off that security notice. Right. I think this is where we were. That while we were offline briefly, did you all do that show of hands? I did ask you questions just while I was going offline. Okay, so what's this global village people keep talking about? How many of you know that regexes actually are locale dependent?
Locale dependent.
And I see Mike looking at me like, are you bullshitting me? No, I'm not bullshitting you. The regexes are locale dependent, and it's not regexes per se, it's those shortcut codes. So let's have a look at those. The /D, /W, /S, /H, /V. First of all, if you use regex with various engines, so you might use Python and Perl and PHP, or even just PHP and you use MB string as well as PCRE, those character classes have different characters in them. Not so much with the digits, but with the white space, yeah, definitely. There are some implementations which will have all the Unicode white space in them, some which don't, some which may have vertical spaces in them, some which don't. So first of all, they are not cross-platform. Remember this very, very carefully. Second of all, they are locale dependent. This can be a really good thing if you have an application which needs to switch locale and you want to be the regex to behave locale dependent. Except in most cases, that's not the situation. Like with that Twitter regex, if we use /W thinking that's A to Z, 0 to 9 and an underscore, that's not going to work as you'd expect. Especially if you remember that if you use PHP on a non-thread safe platform, which is still quite common, locale can be set in a different thread and change your application's behavior because it's not thread safe. So what I mean by this, we've got a phrase, very simple, deja vu. We give it a character class with a /W and a space. Will this match? No, it doesn't, because the E accent and the A both have an accent, so they're not going to match. However, if I switch locale now to French, yes, we have a match. So be very, 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 very wary when you use those shortcuts. Think 2-3 times if that really is what you want. If you want A to Z, 0 to 9 and the underscore, do not use \W because you might run into problems which you did not expect. Escape and escape again. Well, we already talked a little about escaping when I mentioned using different delimiters. Now, what about if we want to match a literal backslash? Because backslash is the way to escape something. And so if you want to use the delimiter within your regex, you'd escape it with a backslash. Okay, but what do you need to escape? Okay, all the meta characters which have special meaning in a regex and possibly have special meaning in your programming language. So if you have a double quoted string and you use \n, you might need to escape the backslash there because otherwise it will use a new line. The regex delimiter, which I just mentioned, and possibly a string delimiter. Because if you want to use a single quote in your single quoted string, yeah. Okay, so how do we do that? Well, the default is the backslash, but it becomes very difficult to read. It becomes more and more unreadable the more and more of these characters you need to escape. So is there a simple trick for that? Yes. Nearly all of those characters lose their special meaning when they're used in a character class. So if you use them in a character class, first of all, it makes it very clear it's the character you're matching. It is not a character with special meaning. Second of all, it just keeps your regex cleaner instead of having all the escaping continuously. Now, what about if we have arbitrary input which we want to use in a regex? Say you have a pattern regex and there's one part in the regex which comes from an array of different values and you want to add that. Or user inputs. You never know, sometimes you do use user input as well. You need to escape that arbitrary string for usage in regex. And you do that by making sure that the regex knows what your delimiter is and knows what are the meta characters of the engine, and therefore you escape those within the arbitrary string. A lot of programming languages, as you can see here, already have built-in functions to do that. Please do pass it the delimiter character you use. If you do not do that, it might escape it incorrectly. Now, there are also some programming languages which don't have a built-in function for this, like JavaScript. Fun times. So what do? We use a regex to escape an arbitrary string to be used in a regex. Yeah, and this is the regex to use. Do not try to read it, your brain will hurt, but it does work. And yes, the slides will be online, so you don't have to scribble and copy it quickly now. Right, now what about matching a literal backslash? What if I actually want to match the backslash in my regex? How many of you have had problems doing this before? And when I normally ask this in a room, about half the hands go up. Okay, I'm going to explain how you do it and why. First, we have the actual backslash. Then we escape it for using regex. So we add a second backslash. Then we add 2 more backslashes to escape those backslashes for the fact that they're being used in a string. So to match a literal backslash with a regular expression, you need 4 backslashes. And yeah, this is really ugly, but it is the way it is, and it is how it works. Mm-hmm. Okay. Now we've had the difficult part. Let's have some fun. Modifying your behavior. How do modifiers affect regex? Modifiers are not part of the regex. They are an extra command you actually provide to the engine on how the engine should interpret the regex. That can be, let's make this regex case insensitive. The I is a very well-known modifier, very much used. But sometimes you have more complex situations, like you want to change the behavior midway a regex. So you have part of the regex which is case sensitive and part which is case insensitive. You can do that by just adding this little snippet at the point where you want to change the behavior. You can also undo it. Say you have a regex which has an I modifier, and halfway the regex you want the rest of the regex not to be case sensitive. To be case sensitive, you can remove the I modifier halfway the regex by just having this snippet in line. You can even combine modifiers in one snippet. And if you just want to use it for a subpattern, you can do that as well. These are powerful features of regex, which are rarely used, but can actually be really useful. Another powerful feature, actually, before I move on to that, explore what modifiers are available. I'm mentioning a number of them here on this slide, and some of them are not available in PHP, like the Y is only JavaScript. But for the languages in which you use regex, have a look at the manual, see what's available and what's supported, because they vary wildly, because it's often to do with how the engine is implemented in the particular programming language. So those modifiers don't always translate across different engines, let alone across different programming languages. So have a good look at the manual for those. Another fun feature is documenting your regex. Say you have a really long, complex regex. Now you can break that up and string concatenate it together and have little comments in between to explain what you're doing. Or you can have a really long doc block at the top of your regex constant where you're explaining what that regex is supposed to do, and it might still be really difficult to understand. Now there's a way to simply do this with regex syntax. And that's using the X modifier. You see the X at the end behind the backslash here. What the X modifier does is it basically says, ignore every single whitespace character within the regex and ignore everything after a hash character to the end of the line. So if you want to match literal whitespace character in this regex, I would have to put it within a character class, so within square brackets, and then I can match a literal whitespace character if I use the X modifier. Other than that, every single whitespace character will be ignored. But using this, I can spread out this regex, and this is an IP character, an IP mask regex. I can spread it out, explain behind each part what it does and why, how it does it. It's a good way to document your regex and to pass on the information what you learned how to do it to the next person who looks at your code. Lastly, what's in a name? Well, sometimes, well, you know, when you have a match and you have a number of subpatterns you're going to use. Okay, so it sort of looks like this. You have the complete match and then several submatches. And then, okay, you adjust the regex and you have to add another subpattern and you forget to not remember it. And it adds another number. So now you have to renumber all the different matches you're going to use in the rest of your code because the array indexes are different. This can get really inconvenient and it's not very descriptive. There's a better way to do that. You can name subpatterns. And if you use PCRE in PHP, you can even reuse named subpatterns. So with that regex we just saw earlier, where with the IP mask, the first part and the second part are basically the same, with the one difference being that after the first part I want a dot. But part of the actual matching of the IP range is the same in the first part of the regex and the second part. If I'd named that first part, I could just have repeated the name for the second part instead of repeating the regex. Similar, if I name my subpatterns, Instead of getting that numeric match array, I still get the 0 for the complete match, but now I get a named. And if you add an extra subpattern into your regex at a later point, those names will not change. They will stay the same. So you do not have to renumber everything in the rest of your code when you're referring to the subpatterns. You can just refer to them by name. And yes, I know it may sound obvious, but for every regex you use, please test. And there's hundreds of sites online. Well, that may be a bit overstating it. Okay, tens of different sites online with which you can use to test your regex. The one thing I should really point out there is please make sure that regex engine, that regex test site you use uses the engine you intend to use the regex with. Most online test tools are based on JavaScript. And if we're talking regex, JavaScript is the lowest common denominator. Yes, you can do JavaScript, regex in JavaScript, and it's quite powerful. But if we're talking features which are available, they have the least amount of features available to them. So if you use, for instance, PHP, there's a lot more features available, and your regex would fail if you use a JavaScript-based testing tool. At the same time, it might pass in a Ruby one, but fail in PHP, because the engines are not the same. So make sure you use the right engine, a test tool which uses the right engine. I myself really like regex101.com. They have a number of different engines available, so you can actually choose which engine to use. And they also have some awesome debugging features available, which will show you how the regex backtraces against a certain string. So you can analyze the performance of your regex with the tooling they provide. Before we finish, I have to quote Richard Feynman. I mean, he's awesome. What I cannot create, I do not understand, know how to solve every problem that has been solved. With regex, it's incredibly tempting to go onto Stack Overflow, search for a question where someone had a similar problem as you had, copy and paste the regex someone posted there, and just trust it works. Please do not do that. Please try at least to understand what that regex is doing, and to really verify if that regex actually solves your problem or only sort of solves your problem. So really do try to understand every regex you use, and don't just copy and paste from a regex collection site or Stack Overflow. Of course, there's more, but we only have an hour. So I'm just going to mention some extra advanced features. Looking around, looking ahead, looking behind, making sure something is not followed by something, but not capturing that extra part. Conditional subpatterns, yes, you can do if then else within a regex. May not be the best way to do it, but it does work, and it can be useful in exceptional circumstances. Recursion is the road to madness in regex. Only for the brave at heart, and even then I would recommend you find another hobby. Inline comments, we already talked about that. So this was basically a quick walk through some of the intermediate regex features. Hopefully I've given you something to think about, how to make your regexes more performant, how to avoid backtracing as much as possible, how to use regex only and really only when needed. Joined In has our talks registered, with grateful thanks to the people of PHPBenelux, so please feel free to leave feedback. And the slides will be up on Speaker Deck. And if you really want to go into a lot more depth than this and still stay with the fundamentals, please go to Pluralsight and watch the course. Mike, you've been not and sometimes staring at the screen, and scrutinizing what the hell I was doing there.
Yes.
Can you tell me how people have been responding?
Well, the majority of people are very, very successful and praise you a lot for this. We do have questions, so let's go to Q&A mode. We already had this one. Oh, people have been using the Q&A for chatting.
Oh, you didn't turn it off after Arno.
And here's one.
Should I stop sharing my screen or?
No, you can use the microphone and the camera.
Okay.
This is a question from YouTube, from Gnaus Demetrius. Can you enable the E modifier in PHP 5 with ?E and then between brackets? You will probably see it on the screen.
I don't see it because I see my slides. But I presume you mean the modifiers? Yes, that works in PHP 5 as well. I don't know the exact version in which support was added, but I'm pretty sure I've used it in as far back as 5.4. So at least in that version, but give it a try. I'm pretty sure it's a reasonably old feature, and it's just not that much used.
Okay, yeah. On YouTube, I see him referring maybe what modifiers can be used on PHP 5, and he verified it doesn't accept the E modifier, but
I'm trying to think now. The E or the I? The
E.
The E isn't that evil? Well, that was removed in PHP 7, wasn't it? To evaluate and replaced by regex. Yeah, that was evil. Do not use that anyway. Please don't. Just don't.
Well, I started my career in Perl, so for me, regex was basically the way to program applications.
Yeah, Perl is basically 100 different regular expressions given some names. There are quotes from, I'm misquoting someone now, but there are quotes from people in the Perl community who actually call Perl that.
Okay, next questions. GS regex P is easier to learn. Preg is a lot more powerful. Okay, yeah, that's just a statement. Is there any static analysis tool to inspect, validate regex?
I need to try and understand the question better. The static analysis tool to inspect how the regex works, or?
Well, the question is to inspect/validate regex. So I presume it's based on the engine that you can validate your regular expression.
Yeah, but I mean, that's when we get back to those testing tools. There's actually some visualization tools, and I need to look up the URL. I don't know those all by heart. There's some really awesome visualization tools which will show you exactly the path, the paths available within the regex and the paths taken for certain strings, which is a good way to analyze how the regex works. I'm not sure if that's what the person means. When I think static analysis tools, I'm thinking tools which you would use in your continuous integration. And I don't know of any which do regex validation within continuous integration. But there are good testing tools like Regex 101, which will show you how the backtracing is done, which will really help you to optimize your regex if you study that properly. Like those visualization tools to really understand how the regex is being walked through, which can be used for those kind of analysis. But that is not something which can be easily automated.
Okay. Yeah.
Not as far as I know, anyway.
Let's have a look here. To avoid the local issues, can we just force UTF-8 mode?
That would be great if you control your environment. If you control the environment, that's absolutely fine. Just force UTF-8 mode. And hey, even better, you can use the Regex UTF-8 character classes, which are really powerful again. However, if you don't control the environment, the PCRE can be compiled without Unicode support. So, yeah, you might want to enable it, but there's no guarantee it's actually compiled with Unicode support. It's rare nowadays to come across PCRE compiled without Unicode support, but it does happen. So be aware of that. Does that answer the question?
I don't see the responses directly, but I think so. So, okay.
Any more questions?
Let me just check Slack here for a second. Oh yeah, it's.
The great feature of being online and then having 4 different places to check things. Are things being said on Twitter? Are things being said on Slack? Are things being said in the chat window? Or maybe at the Meetup page? Yeah, we'll get there.
I don't see any questions left. Also, YouTube is satisfied with the answer.
Okay. Very happy to hear that.
So,
as I said, the slides will be up on SpeakerDeck, and I really appreciate it if you'd leave some feedback on Joined In, and I'll post a link to SpeakerDeck at Joined In as well, so you can find it. Thank you for having me here.
Well, thank you for coming all the way over here. So I'm very, very happy that even in this crisis that we're able to do this. I will share some behind the scenes.
I mean, seriously, I mean, giving me the opportunity, even from 2 meter distance, to give you a virtual hug, being able to see each other's face is so much nicer than doing video chat. So it is a total pleasure to be here.
Yeah.
I cannot agree more. So I think that the majority of people here are waiting for something.
What would that be? Did it start with an R? And next A? Paul, chip in.
Sure, yes.
Double F maybe?
That is most likely the case.
All right, let me get some.
Ah, now we're talking.
Maybe go full screen now. Sure, camera.
All right.
So, let me see if I can do my opening browser. I want my Chrome tab. Here you go. So, everyone that was in Meetup registered, I have your names here. So I'm going to, oh, I see my name in there. There you go.
Hey, we're allowed to participate. We can always give it back if we already have enough elephants.
Well, that's the thing. I want to have it. Let's shuffle it. And I'm going to spin it. And
I think it's already stopped. Huh? Still moving?
all right, Raul, I'm going to copy your name here for a second. Do we have Rahul in the audience? Yeah, you have to be present to win. So
I think
after this session, I will contact you, Sonar, and we will have to exchange some shipping details, and I will send you a very exclusive PHPBenelux care package that includes the elephant. Any requests regarding the color, blue or pink? Is typing. Ta-da-ta-da-ta-da. The blue one, okay. You already won, so I'm going to continue here. Geert van Bommel, are you present? Also on Slack? No mentioning on Geert. Okay. Sorry, Geert. Gilliard Damme. No, Gilliard Damme? Well, the wheel is getting more visible. Carola Gordillo. Do we have?
We should actually a list of proactive fields.
Mike, you're not having much luck. Should we just do regex with the names of the attendees?
Well, this is the list of attendees. So, yeah, but
It's the list of the people who registered, isn't it? It's not the list of the people who actually are here.
yeah, but I can only get that list after the session. So,
Yeah.
One more try. Jurik Schram. No? All right. How are we going to do this? Let's see whom asked. Who was the most active one? Yeah. Yeah. Milana also there. Evil Gabriel.
Who's coming up now? Oh yeah, they're not spinning the wheel anymore.
Spin again, Mike. Spin again, Mike.
Shall we spin again?
Yeah, go for it. Go for it. Go for it. Go for it.
Gabriel.
Nice. Well done. Congrats, Gabriel.
You have the pink elephant, even though I probably should have your contact information. That was more than a year ago, so I removed it. So you need to exchange your details with me again. So, having this said, thank you all for participating. I really enjoyed doing this. First time that I actually got involved with all this. I also want to thank Paul for being here and being the backup in the room. And of course, Juliette for driving all the way from Amsterdam to here, just to have a good time here talking about Regex, which is, yeah, it's still mind-blowing. So thank you very much. And to everyone here on this platform, it's the first time that we did this. We're still trying to learn a lot of tools and how things are working. Yeah. So we want your feedback. What did you like? What didn't you like? What are features that you're looking for that we're not providing right now? Just give us feedback how to do it better next time. I hope the setup with stream on YouTube was also a good alternative. So yeah, I hope that you all enjoyed this evening, and we will let you know next month when we have the next virtual meetup. All right. Well, from all of us here, come around.
With distance.
Distance.
Yes. So everyone, can we? Yep. All right. Everyone, bye-bye. Have a good evening, and see you all next time.
I have a feeling.
Jij bent nog live.